35,000 kilometers above the Earth, a satellite is constantly watching over us. It sees hurricanes forming, wildfires raging, and even volcanic eruptions, tracking it all in real time. This is GOES-18, one of the most advanced weather satellites ever launched. But how does it actually work? And how am I able to receive live images from it right from my own backyard? Let's jump right in. GOES-18 is part of the Geostationary Operational Environmental Satellite Program, which means it sits in a fixed position above the Earth, constantly watching the same region, along with GOES-16, 17, and soon 19, with GOES-19 to be replacing the older 16 this spring. GOES-18 primarily covers the Pacific Ocean and the western United States, helping meteorologists track major weather events with near-instant updates. Compared with previous satellites, GOES-18 captures higher resolution images, updates more frequently, and can even detect subtle atmospheric changes. GOES-18 doesn't just take regular pictures. It uses multiple sensors to analyze the Earth's atmosphere. This includes visible light, which is what we'd see with our own eyys. Infrared, this tracks heat, allowing us to see storms even at night and detect wildfires in real time. And water vapor. This shows the moisture in the atmosphere, helping to predict storm development. By combining all this data, GOES-18 gives scientists an incredibly detailed look at our planet's weather.
Alright, so this is my current antenna setup. You'll see at the top there is the dish antenna. And this one's tuned to 1400 to 1700 megahertz. And we're looking for 1694. So perfect for what we're looking for. And then I'll move over there and I'll point it out. But underneath it, attached right above the box, is the LNA, the low noise adapter. And then in the box is the RTL SDR and the Raspberry Pi. So I'll go closer and I'll show each one up close. Alright, so right here is the LNA, the low noise adapter. And then I'll pop open the box. It's starting to snow, so I'll do this quickly. So that's the SDR, and obviously that's the Pi. And if you do this setup, make sure you're running a good power adapter. Make sure it's 5.5 volt, at least 2 amp, or like I was getting no signal with a crappy cable, and then I switched it and it was so much better. I better go back inside. The compression on this video is going to be terrible soon. But yeah, it's working out pretty well so far. This setup is pretty temporary. I have it sitting in a planter right now. But what I'm thinking is I'm going to run a longer cable and to a nice waterproof box on the ground. That way I can lay out everything properly and not have it shoved into this box, because there's not a lot of room right now. But yeah, that's pretty much it for the setup. It's getting pretty cold out here, so I'm gonna go back inside. Alright, so we're at the computer now, and first I'm gonna show you our GOES receive. So that's receiving the information from the satellite and processing it to GOES proc, which is the processor. So we'll screen into our receive, and you'll see our VIT average is 510, our RS, Reed Solomon, is 610, packets 58, drops 0, so honestly I'm not really sure how good that is. Hopefully somebody could tell me. But we'll go to the proc, and we are receiving. So we got our full channel, or full disk, channel 9 up here, and then all of our MWin text, which is just getting voided
the text gets voided, the images stay. So now we will head over to the program that I wrote to get us into. So this transfers all the images at 2 a.m. to the NAS. And I haven't added the delete function yet, but I'm thinking that I probably will soon because the Pi is getting pretty full. But it's nice because everything just goes into the NAS and we have all of our full disk, full channels in here. Just started, I have other dumps in here. So we got all the dumps in here. And then I have Vitality Goes running. And this is super nice. Like being able to scroll through all the images on a web server is amazing. So I'll leave links to all this in the description, of course. And I mean, once it's all set up, it's pretty much just running all the time, and I can scroll back pretty far. I'm at February 1st, 10 p.m. now. And it takes a little bit to load because of the Pi, but eventually we'll get there. I'll show some time lapses and all that, and yeah. That's going to do it for this video. I really hope you enjoyed it. I've really enjoyed doing this with the satellites. And I highly encourage you guys to get into it because why not? It's out there, it's free. I mean, even if you're in the UK, there's polar orbiting satellites that you can grab as well. I think there's some geostationary ones as well. And it's really not that hard. If you guys want me to do a tutorial in another video, I'm more than happy to. But I would recommend checking out SaveitforParts. He's much more knowledgeable about this than I am, and I'm still learning, is what I'm trying to say. So I'll put links to all the hardware and software and NOAA images in the description. Thanks for watching, and have a great day.